Okay. Okay, good afternoon, everyone. This is James Theuri here, and I'm with Laurie George, and you can see our pictures there, and I'm sure you can tell who is who. And both of us are small farm educators, local food system small farm educators with the University of Illinois Extension. And we are so glad to have you. 33 people have signed up, and we hope they will still join us. 12 states are represented here, and 2 countries, USA and Mexico, are represented, but not everybody is in yet. So you now know what to do with questions. If you have any questions during the presentation, which is going to be an hour, please type in your questions, and one of us who is free will try and answer them. If we can, we'll let you know. And we will be very brief on our topics here because the scope of this subject or this topic is huge. It's wide. We will not be able to go into depth. And then again, we have participants from all types of ecological zones. If you go from Wisconsin all the way to Mexico, then there's a whole range of differences here in terms of ecozones. So there's quite a bit of adversity. But I'll get going right away because of time. And I open up by saying, as the demand for organic or naturally produced foods continues to grow, so will the need for improved production systems to fill this demand. Organic farming takes place mostly on small farms, and today we are going to look at various options that are available to manage. Keyword, manage, not control. When we talk of control, we're talking about killing and eliminating with the most rapid method possible. And you know that's what chemicals do. It's different when you are managing pests or even pathogens. And so we'll be talking about management more than controlling. And we do hope that you'll take one or a few messages home. And better yet, if you can apply any one of them, that would make us feel good, and we would love to hear your feedback sometime in the future. As we go along, also think about what specific topics you'd like us to deal with. We can take late blight in potatoes and talk about it for a whole hour. I mean, it's just lots of information out there. But please let us know of the specifics you'd like us to deal with. Now, before we get going here, we would like to make sure that you are up to same level with us in terms. What's a pathogen? It's a disease-causing organism, and it could be a fungus, it could be a bacterium, it could be a virus or a nematode. Any one of those that is causing diseases. And we have others as well, dodder and other parasitic plants could be considered pathogens. And then there's a difference between a disease and symptom. A disease would be manifestation of infection. Once you get infected, or once a plant is infected, it has some outward signs that we can tell that it is not looking normal. And and then there's a difference between signs and symptoms. A sign is a part of the pathogen. If you leave your bread out on the table and it gets moldy, the mold that you're seeing is actually a sign. It's a part of the pathogen. Sometimes observable by the naked eye, sometimes not observable. And then what's organic? Depends on who you ask. But these are practices that we feel address the soil quality, and we'll stop talking about quality in a second and you see why. And then the use of additives that are considered non-synthetic, non-chemical, things that are biologically produced, as you can see down there. And then that disease is as a result of the interaction of 3 factors: a host, and that has to be a susceptible host. And then the environment, a suitable environment, and then a pathogen that is virulent. Some pathogens, although they are disease-causing, may not be strong enough, may not have the vigor with which to cause infection or disease. But then you also need time. You can have all these three, but you don't have time. You can't just get a disease within minutes. It has to take, it takes time, and various diseases take different amounts of time. And when it comes to symptoms, some plants don't show symptoms even when they have the pathogen in them, and we refer to them as latent infections. So there, what you're seeing there is leaf spots on bean. You got streak symptoms. The first one is actually due to fungus. The second one, streak on corn, is due to virus. This is bean roots that you see on the third picture there due to nematodes. You get those galls. And then you're seeing some cucurbit plant with powdery mildew signs, because this is a part of the pathogen itself. And then down there you see bread that has bread mold on it, penicillium or some other fungus. And finally, you see the apple leaf there, the terminal part of a twig, which is having that shepherd's crook symptom. That is due to fire blight. Okay. And then again, just to illustrate again what is disease, to a layman, a disease is any abnormal condition. I have had somebody who killed their blueberry plants because they didn't water them, but when they called me, they said they were diseased, and I just go there and say, hey, you didn't give your plants water. How are you expecting them to survive in this sandy soil condition? So any condition that deviates from the normal, and you can see those cucumber fruits that are affected by a virus. The tomatoes are also sick, so to, in quotes, for plant pathologists like me, they are not really sick per se. This is blossom end rot, which is caused by calcium deficiency. It's an environmental issue. And then you have the third one there showing leaf spots, the chlorotic ones, the yellow spots there. And so the pathogens are just simply competing for resources with the host. So again, just another quick picture there, signs and symptoms. If you see on the first picture there, the left, that's root rot caused by sclerotinia. It's a fungus that inhabits the soil. The white mass there you see is a part of the pathogen, so it's a sign. On the other hand, the yellowing is a symptom. It's due to fungus infection on a leaf. And this is also just another picture of a plant. This is actually a potato plant showing the left half with healthy situation, the right half, the left half with healthy situation, the right half with infected leaves and fruits and twigs and roots, the leaf curling there, all those things. And the various pathogens there that we just talked about that can cause a whole lot of things. At the soil crown line, you see what we call bacterial infection causing root galling. It's due to Agrobacterium tumefaciens. So in organic farming systems, or let me start by saying, in conventional farming, it's maintained by a continuous external input of all sorts of things to provide nutrients and then keep pests and diseases under control. On the other hand, when you get to organic farming, one strives for a healthy ecosystem, and we'll be talking about healthy ecosystem throughout. And when you have a healthy ecosystem, you have a high biological diversity. And then you have minimal nutrient losses. And you have natural buffering capacity against diseases and pests. Lots of words there, but they will become clearer as we go along. So for organic farming systems, keep this in mind, it takes years to achieve the desired microbial and chemical equilibriums or equilibria with relative stability. Therefore, if you are to decide to turn into organic farming today and you start finding yourself being hit by outbreaks of disease or pests, just take your time. You get there, you have to wait for a little while. You don't have a silver bullet here just to get from week 1 to the next week. Okay? And I'll let Laurie take over from here.
Okay, so what we're going to talk about first is integrated pest management. If you're not familiar with the IPM process or integrated pest management, what we try and do is to integrate several things, especially in organic gardening, prior to using any type of pesticides or fungicides. And even with organic gardening, you're going to have to use something at some point. But we try and incorporate things prior to that first. So what we look at is to look at the biological controls. This is going to be the use of natural enemies such as predators, natural occurring pathogens to help reduce the competitive advantage of some of these exotic invasive weed and insect pests, maybe some nematodes or plant pathogens that are coming up. So that's the first thing that we try and do, is to incorporate something as far as a natural enemy. The second step, if that doesn't work, then you try and use other tools or incorporate other tools while you're using those biologicals. And these are going to be things such as cultural control, grazing, crop rotations, any type of tillage, reduced tillage or no tillage. What type of cultivation are you using? Maybe reseeding, things like that. Mechanical controls, these are going to be prescribed fire depending on what you're trying to control. Any type of mowing or clipping, something that's going to be mechanical. There's a lot out in genetics and host plant resistance. These are things that when you look at the catalogs, you say this is resistant or this has some tolerance to this disease. So these are some of the genetic and host plant resistant areas that you're going to be looking at. Maybe something to do with pheromones, that having to do with insect control or sterile male techniques in order to reduce the population of insects as it comes through your area. And then pesticides is going to be the last resort. So we try not to incorporate that if possible. As growers move away from the IPM foundation that's set here, they will experience increasing costs and environmental impacts. And it's also going to decrease the sustainability and species diversity within your farm. So all of these are going to be important. So when we start talking about our diseases, keep in mind this triangle and how you can try and change things on your farm. So we're going to start off by talking about a few of these families, plant families. And when you're starting to talk about crop rotation, you need to know what family your crop falls into. So we're going to talk about Solanaceae, which are the nightshades, the peppers, and the eggplants. And the biggest one that you're going to see is early blight. And this affects primarily leaves and stems, but it can result in considerable defoliation and increased chance for tuber infections in potatoes. It generally overwinters in potato tubers or in plant debris, either on the soil surface or in the soil. The environmental factors and plant vigor generally determine when the first early blight lesions occurs. And when we're talking about environmental factors, these are going to be things like frequent rains or dews, and daytime temperatures remain about 75 to 80 degrees Fahrenheit. Generally, early blight symptoms typically begin as the plant canopies start to close. The lesions that you're going to see for early blight are most pronounced on the lower older leaves, less vigorous leaves, and on early maturing varieties. The fungus will penetrate the leaf surface generally through the epidermis. Those spots will develop in 2 to 3 days. Most of these lesions are going to be wind-borne, and they will spread by wind from healthy plants to from unhealthy plants to healthy plants. Management, you're going to try and plant pathogen-free seeds. Fungal seed treatments may not be an option for organic growers. However, seed treatments may be, such as maybe hot water sanitation or something like that. Variety selection, you need to find varieties that work well in your area, that have a resistance to or can tolerate early blight. The second one that's associated with this is late blight, depending on where you live. This is caused by a fungus, Phytophthora infestans. Generally creates dark brown lesions with white fungal growth developing under moist conditions. And you're going to see this later in mid to late season production times. These lesions, once they're established, are very difficult to control. Again, 60 to 80 degrees Fahrenheit. The best thing to do for late blight is use certified seed potatoes, knowing that you're not going to have this disease on there. Good sanitation practices, resistant cultivars, and then scouting in the field when you first see the disease. Next one is anthracnose. Anthracnose symptoms can vary with the plant host. The weather and the time of year the infection occurs is what you're looking at. The angular sunken lesions that you're going to see on both the immature fruit, and it can occur at any time of fruit production. On tomatoes, the fruit becomes susceptible as they approach maturity. So as they start to redden up, you may see this. The biggest thing you're going to see as far as the trademark symptom of this is going to be pink to orange masses of fungal spores that form in concentric rings on the surface of the lesions or the surface of the fruit. It's these concentric rings that you're looking for. The pathogen survives on plant debris from infected crops. The fungus is not soil-borne for long periods of time if there's an absence of infected plant debris, so that's good to know. But the pathogen is also spread via infected seeds. Anthracnose requires wet periods. The spores are splashed from rain or irrigation events, from disease to healthy fruits. They form quickly. You can have 100% yield loss very rapidly if this gets established in your production. Crop rotation is probably the best way to handle this, every 3 to 4 years. For management, what you want to do is no overhead irrigation and do some sort of fungicide application when you first see the disease. We'll talk about wilts. Wilting is the most characteristic symptom as far as verticillium wilt. They appear in the lower leaves of the plants during the warmest part of the day. In the stems near the ground, you'll see presence of vascular streaking. When you're cut longitudinally, such as you see in the picture on the left, the stems will show a light tan colorization of the vascular tissues. The potatoes may show vascular discoloration near the stem end. Symptoms are most prevalent at 65 to 83 degrees. When we start looking at a portion of the plant wilting, such as one stem, such as in the picture, 1 or 2 stems, this is also characteristic of verticillium. You'll see the diseased plants in patches of the growing area. It's not going to be widespread. You may see a plant here or a plant there. It can remain in the soil for as long as 4 to 5 years. When you're talking about fusarium wilt, if the plant's yellow and wilt on one side of the plant or on one side of the leaf, they may have fusarium wilt. Again, the yellowing begins on the bottom leaves, followed by browning and defoliation. Symptoms are most prevalent when the temperatures range from 80 to 90 degrees, and this can remain in the soil for up to 10 years. Part of the management is it's difficult to control once you have it. Try and remove the plant debris. Some resistant varieties may be available, although at this point I'm not familiar with any potato varieties that are resistant to verticillium. Some may be tolerant, so make sure you look at those. Remove and destroy the plant material, crop rotation every 4 to 6 years. Chemical controls or any type of fungicide, there's really nothing that you can do for this. There are soil fumigants that the commercial growers use. but you can maybe try soil solarization, and that's something that James will talk about in a little bit. Bacterial spot, most devastating disease of peppers and tomatoes, generally in warm, moist environments. Once it's present, it's almost impossible to control if the environmental conditions remain favorable. The bacteria will attack the foliage, stems, and the fruits. If you have a lot of defoliation on the plant, it can lead to sun scald on the fruits themselves. It can survive in the seed. Bacteria are going to be splashed to the new foliage. Conditions that favor are crowding of the plants and high humidity. And the bacteria will enter the plant through the stomata on the leaf surface or through wounds on the fruit itself. Some of the management you're going to see is pathogen-free seeds, copper-containing bactericides, resistant cultures, and some sort of bacterial phage, if possible, such as agrophage. And James will be talking about that in a little bit. The other one that's very similar to this is called bacterial speck. These are going to create small black lesions on the leaves, generally in temperatures ranging between 64 and 75 degrees. Abundant rainfall and high humidity help to aid this infection. The difference in these seeds that you're going to see as far as the spots is that the bacterial speck lesions are slightly raised and smaller than the spot, and you can really kind of see that in those two pictures there. So some of the management you're going to see is delay the planting in spring to avoid cool, wet conditions if possible. Use furrow irrigation instead of overhead. And a big one is going to be crop rotation or copper sprays. As far as the cold crops are concerned, the big one is going to be white mold. You're going to see this with white water-soaked necrotic areas that develop on either the fruit themselves or the stems. You're going to see that white mycelial growth that is going to be occurring. It can cause losses in the field, in storage, or under transit and market conditions. So just because you don't see it when you harvest it doesn't mean it won't appear during transit. You survive in the soil for a number of years without susceptible hosts. The wet soil conditions favor the disease development as well as cool temperatures. So on the management, what you're going to try and do, again, crop rotations is the best way. Increase the air circulation so you have the reduction in that fungus. Deep plowing or soil inversion. If you know it's in the field and there's no way that you can get all that crop out, do deep plowing. When you're talking deep, I'm talking maybe 1 to 2 feet deep to get it down in there. Any type of fungicides that you can use that are labeled for the crop are going to be beneficial. Clubroot is another one for the cold crops. You're going to see this on the plant roots before the first sign is noticed above ground. You're going to have abnormal wilting and yellowing of the leaves. If it's affected at the young age, the plant may be stunted and may die. Affected at a later stage of growth, you're not going to have any type of a head growth, especially on your broccoli or Brussels sprouts. This one can live in the soil for 7 to 10 years. Can spread from field to field by infected soil, contaminated water, any type of supplies that you use, infected transplants, soil on farm machinery, and even animals can help spread this. The disease development is favored by high soil moisture, soil temperatures between 64 and 77 degrees. Most of the management that you're going to have on this is disease prevention, if possible, good soil health, and we'll talk about that in a minute. Pathogen-free transplants is going to be the big one, especially if you buy those plugs in. Crop rotation, a good water source, you know it's not going to be contaminated, and any type of liming of the field, as it has been found that this disease is primarily associated with low acidic soils. So if you're having problems, I'd probably do a soil test on that. James?
Okay, as we go on, you're starting to get a feel of some of the things you should do when it comes to managing these diseases. Things like air circulation and clean seed and genetic resistance, sanitation, removing inoculum, something like that, and then rotation and copper sprays. So as I go on, I think I'll be coming up with things like those as well. But I'm going to cover diseases in cucurbits or the cukes. One of them is bacterial wilt and spots caused by a bacterium called Awinia, and it is very serious on mainly cucumber and muskmelons. And you can see that striped cucumber beetle, which actually picks this bacterium as it feeds and as it moves to another plant, it vectors it and takes it over there. Survives on debris. The bacterium will survive on thick material on the ground, which means you have to remove that. That is sanitation now. And then also some symptomless plants. Remember we talked about latent infection. So the plant is infected, but you don't see anything. That would be another way of surviving over the winter. And those two management methods there would be have been found to be effective. A trap crop is one where you attract the cucumber beetles to go to and leave your cucurbits alone, the cucurbit crop that you're growing. And they will stay there because they prefer that crop more than your cucumbers or whatever. And you tend to plant those a little bit sooner than your crop, so that they can, once they emerge, they go there and stay there mostly. So you'll have reduced the amount of infestation. Seed rots and dumping off. When you plant your seedlings and you find them falling on their side, as in the picture, some form of infection may have taken place in the roots. And these three fungi, Fusarium, Rhizoctonia, and Pythium, live in one place, which is called everywhere. Every soil has these three. So they are always around. And when you don't have soil that is pre-treated to remove these pathogens, for example, the soil that you may buy in the garden centers and all, then you may have these pathogens. And so when you plant your seeds in cold and wet soils, you greatly increase the risk. And so just by that little bit of information that I gave you, you just want to control this through cultural practices. Why plant so early when the soil is too cold? Why plant in soil where you have standing water and you're encouraging this fungi? In fact, Phytophthora is also encouraged by standing water. All right. And then there is also the mildews on cucurbits. Powdery mildew as well as downy mildew. They are both mildews, but they have subtle differences, as you can see from this slide. First of all, even from the symptoms. Powdery mildew is powdery. It just looks like you poured some powder on the leaf. Whereas with the downy mildew, you have the chlorosis that you see there, and it is between veins. Sometimes you see it on the lower side, and then it appears on the upper side. And so they are vastly different. Indeed, downy mildew is not even a true fungus. It's a water mold, more related to the algae than to fungi. That's why we don't call it a really true fungus. It belongs to the group of fungi called the oomycetes. And powdery mildew is favored by warmer weather, and it likes a situation where it's humid and not wet. In fact, somebody even said, if you water your plants and they are all wet, this fungus will not colonize it as easily as just when you have dryness but humidity around the leaf. On the other hand, downy mildew likes wet weather, and both of these fungi cannot survive in the northern climates. They may immigrate from the south. So we'll be looking at some ways of managing both of them in a little while. And then anthracnose is another soil inhabiting fungus, also called Coletotrichum. And all cucurbits are susceptible, and it survives in plant debris. It just hangs around there. Okay, and it comes later, as you can see, for us in the north here, in midsummer to late season. So all those things that are listed there for management, resistant varieties, rotation, and using drip irrigation as opposed to sprinkler irrigation, and then good hygienic practices, sanitation, and that fungicides anyway, even the biofungicides that we'll be dealing with, we're talking about in a little while, are of limited value when it comes to anthracnose. And the symptoms are indicated on the right there. Phytophthora is every grower's nightmare anywhere in the world because Phytophthora has so many races, there are so many pathotypes that it is difficult to breed against for resistance. So if you get a gene for one race, you still have probably another 99 races to deal with, or however many races there are. So it's a nightmare. But however, it's favored by wet soil. So if you have an area where you're planting where water is going to be waterlogging the soil, then you're encouraging this fungus. Raised beds solve that problem a little bit. Okay. And it overwinters in plant debris and soil. It can just be there in soil even when there is no plant debris. It's all over the place. And all cucurbits are susceptible. And you have those large water-soaked brown spots on leaves that later get the fungal signs that as you see on the fruit, and the fruit gets mushy anyway and collapse eventually. And I've already mentioned a few things about management. Viruses really get into the cucurbits quite a bit, and you see the whole list of them over there. Cucumber mosaic virus, squash mosaic virus, zucchini yellow mosaic virus, watermelon mosaic virus pathotype 2, watermelon mosaic virus pathotype 1, and that pathotype 1 is also called the papaya ring spot virus. That means it goes into watermelon as well as papaya fruit. So virus diseases go into all cucurbits, and all these viruses require mostly vectors, and they tend to survive in alternate hosts. And their effect depends, of course, on time of infection. That's pretty logical. If it comes in when the seedling is just tiny, that's probably a dead plant right there. If it comes late, plant has already gotten out of the critical period, so that may be a good thing there. Host resistance, starting with clean seed, that's sanitation, and then you manage the vectors, and you yourself being sanitary, not to move equipment around that may be contaminated with the virus, things like those. We get onto the beans that are in the Fabaceae family, and one of the major diseases that farmers are concerned with is the bacterial bean disease, caused, of course, by a bacteria, causes all sorts of symptoms. Down there, you see halo blight. You see the dead necrotic. I don't know. Let me see if I can point out here. Pointer is over here. So you see this pot here is surrounded by a halo around it. That's why it's called halo blight. And then you have this other blight type here, bacterial brown spot right here. And for this, the bean pods are affected like this. This is the bacterial brown spots on the pods. And then you have, I'm sorry, this is the bacterial brown spot that I'm pointing at, and this is how the pods are affected. And this is the halo blight, and this is how on leaf, and this is how the bean pods are affected. So you start off with clean seed, and there's resistance to it, and then you rotate, That was mentioned before. Rotation means you're moving away from where the party should be happening for the fungus, go to where there is no inoculum, and the host will be relatively clean. Avoiding the wet crop. When you move in wet crop and you're picking the fungus on your wet clothing and take it to another plant which is not affected, then you're moving the fungus around. And Laurie talked about deep tillage. If you really have a severe infection this year and you want to plant in the same place next year, then you have to plow deep so that you bury the fungus. Being common mosaic virus is a very serious one in places where it occurs, and it is worldwide in occurrence. The leaves, because you can see it is the young leaves there that are mostly affected, they start capping and curling and misformed, and they are not photosynthesizing very well, in which case the plant is not making maximum amount of food as it should be doing. There is resistance of the hypersensitive type caused by this I gene. Hypersensitive reaction is where if cells are affected by the virus, the plant actually causes a necrotic reaction. Those cells are killed immediately, and that arrests the spread of that virus. So again, since it's a seed-borne virus, you want to start with clean seed, certified clean seed. The Liliaceae family includes the onions, garlics, asparagus, those types of plants. And downy mildew affects them. It's caused by peronospora fungus, which survives on infected debris or on organic matter. And the fungus will enter plants through bulbs or through wounds. And so we start off with grayish white to purple growth, and then you end up with these symptoms that are showing here. Okay, this is a bulb that's affected, and you see an entire crop can be very quickly affected. And so start with clean seed again, do rotation, sanitation, remove the volunteer crops that are growing by themselves because they are hosting the inoculum or the fungus already. And then good air circulation. Do not overcrowd your plants, and that's mostly so with many fungus diseases, fungi diseases. Copper sprays are not as effective as chemical pesticides. Now, copper spray is acceptable organically, but it has been shown to be less effective, but it still does give some protection. And if you use this in an integrated pest management system, it will still give you some advantage. Botrytis on onion, you can see the symptoms there, these white specks on the leaves, and that it can also get into the bulb and cause those black signs. Actually, these are signs because these are sclerotia, which are overwintering spores of the fungus. That's how it survives. So management then means you destroy all the affected material, and somebody asked what rogging means, and that has been responded to. Alternatively, a leaf spot of onion, I've seen this quite a bit. It happens almost everywhere. It's caused by a fungus called Alternaria, and it survives in plant debris as well, and the conidia are blown by wind. Therefore, if you saw infection on one end of the field and the wind is blowing away from there, you should see the progression happening. And in desert areas, heavy dew in the morning favors it as it's blown onto leaves that have water on them. And so again, kind of a repeat here, be sanitary, start with clean seed, don't use overhead sprinkler irrigation, and copper fungicide will help. Asparagus rust, which we don't see too much of in Illinois, but it happens anyway. The Puccinia, well, rusts, first of all, are very difficult to control in any system because, again, rusts have so many races. it's difficult to control them by resistance. Although there are a few varieties now of asparagus that have this resistance. If you have this, do remove the debris from previous plants that were affected. And then if you have your asparagus, if you put straw, mulch them, then the splash dispersal of the pathogen is reduced. And then also air circulation is good because you increase ventilation and the infection is slowed down. All right, we move on to soil health. And let me start off by saying that if you have healthy soil, you're almost going to have, or almost always going to have healthy plants. And what's a healthy soil? It's a functional ecosystem that supports a diverse life in the soil. So when we think about soil, previously, more than say 2 years ago, I always thought of soil quality as one that has all the vital nutrients. If you have N and you have P and you have K, you're good to go. Now, if you don't have them, go buy NPK and come and add them and you're good to go. And you are good to go, yes, for a short while, for a very short while, because next year, if those three are depleted, you have to come back and charge the system. But our friends in USDA are starting to ask us to think differently now. Instead of thinking soil quality, think soil health. And anything that's alive has health. Now, is soil living? You just look at that soil food web there and look at all those things that are, all those organisms that are involved in the food web. And yes, soil you will be referred to as being alive. And if you mess any one of those constituents of the soil ecosystem, you'll be messing with soil health, and you'll be messing with the equilibrium that is in the soil that enables plants to survive and thrive as well as they could. Because when you have everybody playing their part, the plants are also protected somewhat and they receive mineral nutrients much better, and even a little bit of infection by pathogens or infestation by insect pests, they are able to resist. So think differently. Soil quality versus soil health. All right, that's the main message here. To make the point, to emphasize on that point even more, 1 teaspoon of soil has more inhabitants than maybe even on the earth. If you have 100 to have, you have so many organisms in 1 teaspoonful of good, healthy soil, as you can read for yourself over there. More than 100 million bacteria, anything up to 1 billion, and other organisms. All right, so we have all sorts of microorganisms in the soil, as you can see there. Bacteria, what are they good for? They decompose what's in the soil, turn that into mineral nutrients that plants can pick up easily. That's what happens to organic matter. Okay, and mycorrhizae have a very good association with plant roots, and because of that association, the mycorrhizae benefit by getting exudates from the host, and the plant, through its roots, is able to access nutrients much better than if there were no mycorrhizae. And so these microorganisms like to inhabit or be around the root systems because they can get some food. But the root systems also get micronutrients as these fungi and bacteria avail these mineral nutrients to them. So there is a mutualistic and beneficial association between microorganisms and root systems, And that area where they are colonizing or inhabiting is the rhizosphere. And you can now start to see why when we add NPK there, we start messing up with these systems. Plants are not as vigorous and growing as well as they should be over the long term. Okay. One way of amending the soil so that we encourage all these microorganisms to grow is by adding compost. Now, compost, once it's broken, well, so if you're using compost, compost should be very well decomposed. That's why we are calling it compost. Manure is not compost because it's not been broken down. But once it's broken down real good by bacteria, and then, and this is very critical, and you see the last statement there, then allowed to cure. Curing process of anything between 2 to 4 months, that stabilizes the compost. And what that means, and one of the things that happens then is that that compost is repopulated by beneficial microorganisms, be they bacteria or fungi. So when you add them to your soil or your garden or farm, you have lots of good things coming in. I know we are not going to talk much about compost teas today because of the variability of results of various researches and reports, but they are supposedly very good as well if used properly. So by adding good compost into the soil, you encourage the plant growth promoting rhizobacteria. So that's going into, associating with the roots and other microbes. And vetch is a cover crop. We'll be talking about cover crops in a second. But the mulch from it also does encourage the plant growth promoting rhizobacteria. And once the roots sense these rhizobacteria, they are induced, or the plant is induced to develop antibodies in quotes. This is in quotes. You don't get antibodies in plants, but you get the systemic acquired resistance, which is not, well, similar but not identical to us when we get an attenuated vaccine and we develop resistance because we make antibodies. There is a systemic acquired resistance that happens in the plants when fed with good compost that will encourage the plant growth promoting rhizobacteria. A little table here that is showing you the benefits of compost. This experiment was done in Ohio, where radish were grown, and one group of them were exposed, or both groups of radishes in 2 different experiments were exposed to rhizoctonia. And in one group of the radishes, compost was added, and the other one was not added. And you can see here that with the diseased rhizoctonia, you had 3 times as much rhizoctonia infection as when you had compost. So compost was definitely giving an advantage here. The total yield when you had no compost was 2, and in the composted plot, you had twice as much yield. When it came to marketable yield, yes, you can see that most fruits in this experiment were messed up. You had very few marketable radishes here, whereas in the composted plot, you had 7 times as much marketable number of radishes. So that tells you right there that composting does have a good benefit.
Okay, so what we're going to do is to talk a little bit about cover crops or green manures, and being an organic grower, it's important that you try and incorporate some sort of cover crops into your systems. So what are cover crops if you've never used them? Generally, you're going to use them to help cover the bare ground, to help suppress some of the weeds or weed seeds that are going to be germinating in your fields. You want to be able to prevent erosion. So if you do till or do any type of tillage on there, the application of cover crops are going to help to reduce the amount of erosion or wind-blown soil that can be occurring on that. They also sequester nutrients to help keep the nutrients in the soil, especially if you're using any type of cover crop that are of the legume families, such as the clovers. They tend to help fix nitrogen into the soil, which is going to be really beneficial if you have a high nitrogen crop that's going in after it. It'll help keep the soil cool and help provide the root biomass that those micronutrients and other microbes in the soil are going to need. According to the USDA Economic Research Service, I just put this out today, they're stating that farmers plant cover crops or cover mixes between the plantings of most of the crops. So you can do it in association with your crop or after or just before you plant your cash crop. The reasons, again, is to reduce erosion, preserve soil moisture, increase the organic matter. Common cover crops, as I mentioned, like clover, field peas, annual ryegrass. These are some of the things that you can start incorporating. Hairy vetch or vetches are also very good for that. The cover crops are not harvested, so they don't provide revenue for you unless you want to try and harvest for one other reason or another, but they don't have a cash benefit to you. Some of the farmers can get direct value over a cover crop if you're going to maybe graze your livestock on it. According to the USDA, the use of cover crops is more common in the southern and eastern parts of the United States throughout, and so that's kind of an interesting item that they came up with today. And that could be related to differences in climate, agricultural markets, and maybe some state incentive projects that you may have where you live. Second thing I wanted to point out to this was using cover crops for control of fruit rot in pumpkin, and this was a study that was done back in 2011, and it talked about using the cover crops as far as fusarium fruit rot was concerned. And the results suggested that the cover crop mulches such as winter rye or winter rye with hairy vetch incorporated, or maybe spring sown oat that was killed prior to the cash crop, and having those cover crops left on the soil surface may help reduce losses to fusarium fruit rot, especially in pumpkin production. In Illinois, pumpkin production is number one, and so in its over conventional production, so there is some sort of benefit associated with it. The cover crop mulch layer may prevent direct contact between the soil-borne pathogen and the pumpkin fruit by acting as a physical barrier. This physical barrier will help reduce the fusarium fruit rot that may be associated within your system. The physical barrier may potentially help to reduce the direct infection, maybe splashing of the fungal spores, or have other effects on the pathogen growth and the dissemination in the soil of that problem. Talk about crop rotations. Some of the goals on the crop rotations are beneficial. You're going to add nitrogen if you can for any type of crop rotation, especially again if you're going to have any type of a crop that's going to be a high nitrogen. You may want to do a crop rotation where you have something that's going to add the nitrogen into the soil. When you do crop rotations, you're going to help control diseases and insects and weeds. When you have a monoculture of a crop, meaning that you have one crop that you plant year after year, the disease incidence and the insect incidences, since it tends to overwinter in the soil, can build up over time, and then eventually you won't be able to use that soil or that planting area for long periods of time. So crop rotation helps to reduce those diseases and insects. It helps to conserve and build organic matter. We talked about that. It also may help to reduce labor because sometimes you may have beneficials where you have an allelopathy or some sort of chemical that's given off from one plant that may benefit or reduce the amount of incidence of diseases in the soil as the other crop comes in. So there's always good benefits to crop rotations, and that's one of the things we try and emphasize when we talk about our diseases. When we're talking crop rotations, if you're not familiar with them, this is a good table that I found online from raiseyourgarden.com. It is a sample planting guide that they used for 3 years. So it gives you an indication of a raised bed system that they have. They were a smaller type of a grower, but they were organic. And what they're looking at is rotating the Solanaceae and maybe the lettuce crops for the first year planting there. Second one, maybe planting your beans, knowing that you may be having something else coming in on the third year. So laying it out and seeing what you're planting where and then rotating those crops is going to be beneficial. Some of the wisdom associated with it is you want to avoid planting the same crop family in the same field. That's why we try and separate our vegetables by families, because that's going to be the main thing. Alternate cover crops with your cash crops. Okay, we talked about that. And again, precede your heavy feeders of nitrogen with the nitrogen fixing cover crops. And if you're familiar with that, there is a good program or a good website that you can go to that is called Midwest Cover Crop Association. I'm trying to think where the name of that is. It's the Cover Crop Field Guide, Midwest Cover Crop Field Guide, and that is located at mccc.msu.edu. And it's an excellent website that you can go to get information as far as cover crops. James?
We talk about solarization, which is a special mulching process which uses hydrothermal disinfestation. And when you manage to do this hydrothermal disinfestation, other physical biological processes are also benefiting. And indeed, it's been shown that once you do this solarization, nutrients become even more available to plants that are subsequently planted. And this method, as you can see there, is overlaying a clear plastic film on well-prepared soil that has been leveled out nicely, because you don't want lots of air pockets between the plastic and the soil. And then the soil is wetted because you need you need to warm up the soil and warm up the water as well. And this method works very well in hot areas, California, Florida, Israel. They use it quite a bit in the tropics as well. And when you wait for 2 to 4 months, you kill very many pathogens because you achieve anything between 140 to 165 degrees Fahrenheit. Does that kill beneficial organisms as well? Yes. However, once you go back to normal functioning of the soil, the good guys, the beneficial microbes, repopulate faster than the bad guys. And so it's been found to be a very effective way of managing pests, weeds, nematodes, and a lot of pathogens following that procedure that is shown over there. Biofumigation with mustards. Some of you may be familiar with nematodes being a big problem in soil, and the way they used to do it way back when was to apply methyl bromide into the soil, fumigate the soil, then cover the soil and hold that in place for a day, 2 days, 3 days. And so that methyl bromide would kill the nematodes, and you can, as you can imagine, also kills a whole lot of other organisms in the soil. But now they found out that you can actually do the same thing with mustards. The reason why mustard tastes the way it tastes when you taste it is because it's got that mustard component in it, which is very good against insect pests as well as pathogens in the soil. So there's one particular mustard that has been researched on by Joel Groover in Western Illinois University. He calls it the Kodiak mustard. And the goodness with using the mustard is that they're ecologically sound, and while you're using them, you're also using it as a cover crop. So you are improving the soil quality, the tilth, the porosity, all those good things. And of course, it will be organic matter, which will be food eventually for microbes as well as plants. Okay. The only big deal with it is that you have to, if you're going to use it as a fumigant, biofumigant against certain pathogens, then you have to execute its use very well. And those are the plants that you can use. Okay. Now, this particular mustard, which is called Kodiak mustard, that was studied by Joe, is one that releases biotoxic compounds, which are isothiocyanates. And you have to sow it earlier than, well, so this is a cold-loving crop, so you can sow this earlier than other crops that you want to grow. But when you sow this and you wait till 60 to 80% of the plants have gone into flower, you chop them very nicely. In fact, if you just go in there with a lawnmower, chop them into shred the leaves. But if somebody could be following you with a rototiller or a tractor and you immediately till the chopped material under, you will be getting the fumigant gases that are being released by those plants, by those leaves or foliage, into the soil, and you'll be able to suppress a whole lot of soil-borne pathogens. Now, Joel says he has had very good success with this system. I just read about a study in California where they said they tried it. It worked in one of 3 situations, so it would work in 1 plot and not in 2 plots. And so again, there's a little bit of variance in the results, but by and large, most of the literature indicates that it's working and it can be used for other good things as well, as I said. We get into biopesticides. Bio means living. Therefore, a biopesticide would mean a pesticide that was derived from once living or living material. Now, this could be both fungi, bacteria, or plants, or other minerals dug in the ground, whatever. In the US, we do have up to about 300 registered biopesticide active ingredients, and they are mostly used as preventative as opposed to curative. In a few instances, you could be curing what you're seeing, the infection that you're seeing, but mostly you use them as preventative biopesticides. There are 3 classes of biopesticides. The microbial, that the most famous one that you all know is Bt toxin, Bacillus thuringiensis toxin, that is sprayed onto leaves so that when the worms eat those leaves, they ingest the toxin and that messes their gut. That's the one you're most familiar with, but we're not talking about insecticides today. We are talking about fungicides. So there are others, and we'll see them in a second. The biochemical ones would be plant extracts that either attract, repel, or kill insects, like neem, and we'll talk about it in a second. And there are other chemicals that we use, like sex pheromones, which attract insects. Well, it will really attract the male, which drives it away from where it should be going, and then other things too that can be used in like manner. And the advantages of these are that they are less toxic, of course, and they are very specific, mostly specific on the target. A few are broad range, and they are also effective in small doses, and then they do not persist in the environment. They decompose quickly, and they really provide us with a good alternative to synthetic pesticides. So here's a table showing a group of fungicides that are classified as biopesticides. And we are not going to go through all of them, but if I was just to kind of comment a little bit on some of them, if I was to comment on two of them, what's the pointer? Okay, so I'm going to comment on two of them. Copper is one fungicide that is being used forever, and you've probably heard of Bordeaux mixture, which is a copper fungicide. It's been used for a long time, and because of that, organic growers have been allowed to continue using it, especially here in the United States. In Europe, it's been banned even for organic growers, and this is because it's been found to be highly phytotoxic if it's not used in the right manner, or if you use it with others. It becomes highly phytotoxic, and it can also be toxic to insects, beneficial insects, can also be toxic to humans. So according to one piece of literature, it probably will not be around even in the US for a whole lot of time. Sulfur is as old as Jesus Christ, because they said it's older than 2,000 years, and that's the age of Jesus. It's been around again for a whole long time, and it's used very effectively, especially against the mildews, especially the mildews. Horticultural oil will also be effective against the powdery mildew, especially. That one I know of. You see this dormant oils there as one of the chemicals for professionals. Dormant oil does not mean that the oil is dormant. It just simply means it's used on dormant crops, which is in the winter. So more so for fruits when they are they don't have any foliage. Then the other oils, like the all seasons horticultural oil, will be used anytime during the summer when the leaves are on the plant. Neem oil is from a tree originally from India and now growing most everywhere in the tropics. It has neem oil, which is very effective against insects, and now it's also being used against some fungi. Bicarbonates, one of the bicarbonate that you're familiar with is sodium bicarbonate, is baking soda. It's been used well against some of the fungi as well. I got another table here. I'll comment on just two of these listings here. So Serenade, which I circled there and I think you can see, is a bacterial fungicide. It's actually extracted from this Bacillus subtilis. And you can see it's useful against botrytis species. Botrytis, everybody who grows strawberries should know botrytis, because if a strawberry plant touches the ground, you're almost guaranteed it's going to get that moldy stuff, which is actually from botrytis. So it's applicable to the day of harvest, Serenade, that is, and meaning you can spray whatever and eat the same day. It's that harmless to humans. And then it doesn't show any buildup of resistance. That's one. And then viruses, when you spray an attenuated form of the virus, that means a weakened form of the virus onto plants, the plant acquires the systemic acquired resistance that we talked about, similar to that. As Dractin, the one I just circled now, is from a plant called Pyrethrum. It's in the same family as Chrysanthemum, but Pyrethrum grows only in the tropics. And the extract from Pyrethrum is called pyrethrin, which is what Azadirachtin is. Very good. It gives a knockdown effect on insects that it is aimed at, and it does not persist in the environment. And way back when people wanted something that was persistent in the environment, they studied that molecule, pyrethrin molecule, and made a similar but not identical molecule, which we call pyrethroid, and which is very persistent in the environment, which is not likable. It's not good for the environment. And it, as you can see, this insecticide is good against all these insects, which by now you know are good vectors of viruses. Therefore, by knocking off these guys, you are taking care of viruses. So, and then I did not want to leave out Trichoderma hasianum, which is a fungus that is very good at outcompeting. Well, it's a beneficial fungus, and it is so beneficial because it is able to outcompete the bad guys, Pythium, Fusarium, Phytophthora, and other soil-borne fungi. It's able to outcompete them for food and then for space. It's able to colonize the rhizosphere very well. And then it's also been shown to produce antimicrobial exudates that can actually kill other fungi. And the other way it's able to manage or manage fungi is by actually parasitizing them. In this picture, you see this this big, huge hyphostrand, which is, colored it like that. That is Rhizoctonia solanae. And then you have this narrow strand here, which is the hyphostrand of Trichoderma. But beyond that, you see these little outgrowths from the Trichoderma. They are called Hostoria. They actually grow into the hyphostrand of Rhizoctonia, and of course, the Trichoderma starts living off of the nutrients that are in Rhizoctonia. That, of course, weakens the Rhizoctonia, which we know now that it causes dumping off and other root rots. So that's very helpful. And I know you might raise the point that when there is no food for the Trichoderma, it will not survive, which is correct. Once you get rid of all the Rhizoctonia and other fungi, it may not have the food to survive on. If you get a reinfection by the bad guys, you have to re-inoculate with the Trichoderma, maybe by introducing new compost. Or these days you can actually buy Trichoderma and broadcast it into the soil. Short experiment here done with cotton seeds, where the seeds were actually inoculated or coated with a slurry of Trichoderma hasianum, or virens. In this case, this was the species used here. But you can see that when the seeds were not coated with the Trichoderma, the germination rate was poor. And on the other hand, when the seeds were coated with the fungus, germination was 100% and vigor was great, and all those good things. And so in closing, I just want to say that when you have healthy soil, you have healthy plants. And in organic farming, crop protection is oftentimes not directed at controlling in quotes, the pathogens, but you're managing the environment such that plants are able to withstand potential attacks because they're more vigorous. Therefore, organic growers commonly will rely on cultural plant protection methods and substitution of synthetic fertilizers with organic amendments will lead to a microbially driven system and changes in micronutrient supplies. It creates a healthy soil, which in turn allows healthy plants to survive and thrive. And unless, Laurie, you have something else to say here?
No, I think you pretty well covered it. The next
Okay.
slide that we have is the resources that we have for what we used. If you had any questions, so if you want to switch to that one, James.
I just did. I'm on the resources.
Okay.
Oh, wait a minute. Before we go to the questions, anybody wanting to read a little bit more in depth, especially a nice review. I found Van Bruggen et al. They have a very good article that's a review. I would urge you to go there because you get some in-depth information. But if you're just after a listing of the biopesticides and other methods that you can use to control diseases, the first and third, this one and this one, are both very nice. And everything else is good too, but if you can manage to get at least those three.
Okay.
And thank you, first of all, for going 15 minutes over and hanging on. If you have any questions, today and any other day, by the way. So the other thing I would want to say is that a recording is available in case you want to